Okay, great. Thank you so much. Um, all right, great. And then Nicole, if you could just put it in present, that would be great. All right,
Sorry.
awesome. Yep, it's perfect. Thank you so much, Nicole. So I will go ahead and get started. Thank you for that introduction. Um, Sorry, one second. Hello. I am Katie McNally, and I'm a research study coordinator with the All of Us research program at Northwestern. And I have Nicole here with me today, and she's one of our research assistants. So I'm just going to share a little bit about the All of Us research program. So I will go ahead and get started. You can go to the next slide, Nicole. I wanted to start by giving a background on how this program came about and where we got our funding from. So in 2015, during President Obama's State of the Union address, he announced that he was going to launch this precision medicine initiative. He described it as a bold new research effort to revolutionize how we improve health and treat disease. And along with President Obama launching the Precision Medicine Initiative, the 21st Century Cures Act was also signed into law in 2016. And what this act did was it authorized an additional $1.5 billion of funding over 10 years for the National Institutes of Health All of Us research program. And what that means is that our program is funded by the NIH through this 21st Century Cures Act. And I think it's also really important to note here that there was really strong bipartisan support for this bill, so much so that it passed through the Senate with a vote of 95-5. And now that I kind of went over where we got the funding for this program for, I wanted to go in a little more detail about exactly what precision medicine is. So you can go to the next slide, Nicole. In short, precision medicine is individualized healthcare. So at the moment, healthcare really uses this one size fits all model, but we know that doesn't really work for everyone. So what we want to try and do is move away from that so we can have healthcare that's tailored to each individual. So precision medicine takes into account factors like your environment, so where you live, your lifestyle, what you do, and your biology, your genetics. And by taking into account all of those factors and individual differences, we hope researchers will be able to discover new insights. Hopefully, this information will give healthcare providers what they need to make customized recommendations for each individual. And this really is a new and emerging field. So, that's why it's so important we're doing this research. Next slide, please, Nicole. So now that we have that basic understanding of the precision medicine initiative that was launched, what is All of Us? What are our goals? What are we trying to accomplish? We are a part of that initiative, and it is a nationwide research study. It's a historic longitudinal effort to gather data from 1 million or more people living in the United States to accelerate research that may improve health. And when I say longitudinal, what I mean by that is it's a study that takes place over an extended period of time. So for us, that means that this study may last for 10 or more years. Our goal is to build one of the largest and most diverse biomedical data resources of its kind that researchers will be able to use for a wide range of studies that may lead to more customized ways to prevent and treat diseases. And that's really where that precision medicine piece comes into play in our study. Next slide, please, Nicole. Then how is All of Us unique from the typical research program? What makes it different? It's different in a lot of ways, but I just wanted to highlight these 4 key areas on the slide here. So our goals, our breadth, our diversity, and our engagement. The overall goal of All of Us is different from most research studies in that Many research studies focus on a specific disease or population, whereas All of Us plans to serve as a national research resource to inform thousands of studies and will cover a wide variety of health conditions. So, for example, rather than focusing on heart health in males over 65, All of Us is going to be this large database where researchers can pull from and study a wide variety of things. We also aim to build one of the largest health databases of its kind. As the volume of data grows, we may see patterns that wouldn't be visible at a smaller scale. So this resource will grow richer over time as more participants join and the program adds more data types. And then this bottom two buckets on the slide here, diversity and engagement, I really wanted to focus on because these are part of the program's core values. So diversity, we want to make sure we get information from all types of people, especially those who have been underrepresented in research. We aim to engage a community of participants that reflects the diversity of the United States, and that includes people who haven't been invited or able to take part of medical research before. Of current participants we have enrolled, 80% represent communities that have been historically underrepresented in research, including 51% from racial and ethnic minority groups. And we welcome participants who are both healthy and sick of all backgrounds and walks of life. Then this engagement bucket is one that I think really makes our program stand out. And that's we see our participants as partners. And we want participant feedback on every aspect of the program so we can continue to improve and make the program better as we go. We're committed to complete transparency with our participants, and they will have full access to the data they share and the information of the research projects that use All of Us data. So what that means, you don't just come in and share your data with us and then that's it. We return the results of everything you share back to you. So I'm going to go over in more detail what exactly that means, what results you're getting back. So you can go to the next slide, Nicole. So then, why do we need an All of Us research program? I've listed the three big buckets on this slide. So I'll start with for the patients. As I talked about earlier, that one size fits all model, not really working. So patients aren't being properly served by that model, and the treatments that are designed for that quote unquote average patient aren't working. And then for the professional providers, precision medicine is a new field, it's still emerging, and we need all of the data we can get to make research advances. This data may give healthcare providers the information they need to make customized recommendations for people of different backgrounds, ages, and regions. And then lastly, the biomedical researchers. Right now, researchers spend a lot of time and resources creating new IT systems, databases, and analytics, and they also face enormous costs and time to recruit participants. So we're hoping by creating this database, we can help solve some of these issues and do the groundwork for these researchers. And a great example of this database being put to use was recently highlighted during this global pandemic. And I'm going to go into a little bit of more detail about what I mean by that. So you can go into the next slide, Nicole. So COVID-19 highlighted the importance of a research program like All of Us. With its scale and diversity, All of Us has been well positioned to make special contributions to these efforts. We've been able to address COVID-19 through three key initiatives that are listed here on the slide. The first being a survey we released to our current participants called the COVID-19 Participant Experience Survey, or COPE. This survey was sent out for the past year to better understand the impacts of the pandemic, including impacts on physical and mental health. It included questions on COVID-19 symptoms, stress, social distancing, and economic impacts. Next, at the start of the pandemic, we began antibody testing on samples we already had in our biobank. All of Us is testing stored participant blood samples to look for antibodies against the virus that causes COVID-19. We started with participants who joined most recently, and we're still working our way backwards with those samples. The test will show the prevalence of COVID-19 exposure among all of us participants. In particular, we hope this will be able to show us when the coronavirus first appeared in our participants. And we do plan to share what we learned from this research overall with our participants, and that's part of that transparency piece and returning results. Lastly, this EHR integration or electronic health record integration, we're gathering standardized information about COVID-19 from participants' electronic health records to help researchers learn more about symptoms and associated health problems. More than 200,000 participants have shared their electronic health records with the program so far, and that offers a really rich data set for analysis. So that's really great so far. Next slide. And how do you participate? What do we ask of our participants? What's the time commitment? Participation takes about an hour to an hour and a half of your time, and it's broken down into two portions, really. So the first portion is completed completely online and consists of creating your account and then filling out 3 consent forms and 3 surveys. So those consent forms are the general consent to participate, consent to share your electronic health records, and the consent to get your DNA results back. And the surveys are the basics, overall health, and lifestyle. Right now, we're offering telephone appointments to help walk participants through completing that online portion. Or if you need more help or don't have access to the internet, you can come into one of our participant centers to complete that. We have 2 locations, one at Northwestern Memorial Hospital downtown, and then one in the western suburbs in Geneva at Delmore Hospital. The second portion consists of an in-person visit, and we've recently just opened back up our participant center, and we've put into place new safety precautions. These include universal masking, self-report of any symptoms prior to the appointment, health screening once you arrive at your appointment, longer appointment blocks to allow for proper airflow and room sanitation. We've put these in place, among others, to keep our participants and our staff safe. Once you arrive at your in-person appointment, what you can expect is to have your physical measurements taken, and those would include your height, weight, blood pressure, and then we also ask for a blood and urine sample. At the end of that visit, you're compensated with a $25 gift card as a thank you for your time. And then this last bucket here, the wearables and digital apps. This is a newer update to the program. And what it is if you have a Fitbit, you're able to link that to your All of Us account and share that data as well. This is just one example of how the program is always adding to those new data types. Next slide. Then how does the program work? I just went over this first step here. The participants share data, exactly what you share. So you're sharing that survey information, those consents, and the physical measurements and buyer samples. And then after that, it's really important that all of that data you're sharing with us is protected. We want to safeguard participant privacy. So all of us stores all data on a secure encrypted platform that receives routine updates. The program strips data of personal identifiers such as your name, your address, your date of birth, and anything like that. We also have a certificate of confidentiality, which pretty much just states we're not able to release any identifiable information to anybody. After that, approved researchers are going to look at that information and they're going to be able to return what they find to you. And that also goes hand in hand with number 5 on this slide. They're going to be able to look at the information as a whole and pull from there to do those studies and share their discoveries. And one place where you're able to go to look at research studies that are going to be conducted is researchallofus.org. That's where publications and research findings are going to be available, and you don't have to be a participant to access this website. It's open to all. What's the value for participants? Why do people join? Everybody joins for their own reasons, um, but I've just included a few on the slide here, and I'll just quickly go through them. So, all of us provides an opportunity to help researchers better understand disease and make health research breakthroughs. Being able to ensure that your community will be represented in biomedical research and included in studies that could lead to those breakthroughs. By joining, you have a chance to learn about additional research opportunities you may be interested in. And lastly, what I think is one of the biggest values that the program provides back to participants is an opportunity um, that you may learn more about your own health. I mentioned this earlier about getting the information you share with the program back. So I'm going to go into more detail now about exactly what that means. Next slide. One of the benefits of participating is that you can get your DNA results back over time. So, one of the consent forms that I mentioned earlier that you fill out in that online portion is the consent to get your DNA results back. So, if you choose, you're able to get those results back after you come in and donate a blood sample. We can analyze the DNA in that sample. So we look at different types of DNA, such as your ancestry. So that would be information like where your family comes from. We also look at traits, and traits are characteristics or features of a person. So some examples that you could get back are um, could include whether you love or hate cilantro, if you are more likely to taste bitterness in foods than others, if you have wet or dry earwax, if you have trouble digesting dairy products, and so on. You probably already know these things about yourself, but that's just some information that the program would also provide back to you. And then the last one listed on this slide is the health related information. And this could include whether you have an increased risk of developing a serious health condition or how your body might react to certain medications. And here it's also really important to note that all of us is a research program and we do not provide medical care. Next slide. So this type of genetic return of results is of unprecedented scale. All this is the first large population research program to offer health-related DNA results to participants as part of being in the program. With that, we believe returning results in a responsible way is crucial for the program. And so we've partnered with a health technology company called Color to run the program's genetic counseling resource, or our GCR. Through the GCR, will offer educational materials and genetic counselors to help all of us participants understand the DNA results that we're returning to them. So, genetic counselors are trained healthcare professionals who help people understand the DNA results. And the type of support they provide could include connecting participants to local healthcare resources. And again, this would not be a medical consultation. It would be helping participants connect with that medical consultation. It could also include discussion of risk, physician education and understanding, and also helping participants share the results they get with their family members. And then I believe I have one more slide. So, all of us is committed to enabling research in which everyone is seen and counted. With that being said, the only requirements to participate are being 18 years and older, currently residing in the US, and not being incarcerated. We all continue, so it's important and we're committed to continue to meet individuals from all walks of life where they're at. Next slide. So then if you were interested in joining, or if you had additional questions, you can visit our website, which is at nm.org/join all of us, or you can scan, if you have a smartphone, you can scan this QR code and it will bring you directly to the website. And our phone number and our email address are listed on the screen as well. Thank you all so much for your time and your attention.
Great, thanks, Katie. Does anyone have any questions? So I actually had a question. So you mentioned that you're able to integrate data from all different sorts of sources, I guess. So you mentioned about wearables and stuff being used in the future. So could you speak a little bit more about how that might be integrating and what that might inform in terms of personalized medicine?
Yeah, so that's actually a new the we've partnered with Fitbit, and it's one of the newer updates to the program. So if participants already have a Fitbit, they're able to link that information to their account, and so all of the information that Fitbit already collects will go directly into their participant portal. So, for example, like the amount of steps they're taking per day, that kind of goes fits in with the lifestyle and like activity, like how you can think about how much activity you're getting per day. How does that affect other health and lifestyle factors? How is that affecting your health?
Very cool. Well, thanks so much for your talk. And if anyone has any questions, feel free to post them in the chat. If you think of them later, we might be able to have time to address them later. If there's nothing else, then Karis, the floor is yours.
Awesome. Hi, everybody. Can everybody hear me?
Yeah, we can hear you.
Cool. I will share my screen. All right. So, hi, everybody. My name is Karis. I am a graduate student here at Northwestern. I'm in our Driscoll graduate program, so that's our biomedical life sciences program. I'm actually on the downtown Chicago campus because of that, so I'm right by the hospital. I am in the lab of Navdeep Chandel. So what my lab studies is broadly, we study metabolism and the mitochondria, which you may or may not be familiar with as like the powerhouse of the cell. That's what its claim to fame is. But I specifically study mitochondrial dysfunction and metabolism in Parkinson's disease. So I wanted to just talk to everybody today about how do we study and how do we treat Parkinson's disease. I think a lot of people, Parkinson's disease is well known enough that people know kind of generally what it is, but I think a lot of people don't really know how exactly we study it in a lab, and then also what treatments are available and how those treatments work. So that's kind of what we're going to go over today. Feel free to ask questions throughout. You can ask them in the chat. You can just unmute and say it out loud. Feel free to interrupt me. This is kind of meant to be more of a conversation just so that you all can learn more about the brain and how it works and what's going on when it's not doing exactly what it should be doing. So with that, I will get out a pointer and I'll get started. So just a little bit of background on me, just so you can know who I am, what my educational background is like, and also see me without a mask for a second. So my name is Karis D'Alessandro. As I said, I grew up in Tulsa, Oklahoma. So that's me. And then I moved to Baltimore for college. I went to Johns Hopkins. I got my bachelor's degree in neuroscience there. After that, I moved to Nashville for a year. I worked at Vanderbilt in the lab of David Calkins. I actually worked in glaucoma research there. So if anyone has any unrelated questions about that, I can do my best to answer. It's been a couple years since I've been there though, so I might not have every answer. And then after working there, I moved here to Chicago to go to Northwestern. So now I'm a second year PhD student, like I said, in the Driscoll graduate program here at Northwestern. So just a general overview of what we're going to talk about. First, I'm going to talk a little bit about the basic fundamental neuroscience background you need to kind of understand what's going on in Parkinson's disease. Then I'm going to talk about a couple different research methods that we can use in the lab to study Parkinson's disease. And then I'm going to talk about the treatments we have. Unfortunately, we don't have a lot of treatments. There's two main treatments I'm going to talk about, which is L-DOPA which is a pharmaceutical treatment for Parkinson's disease. And then I'm going to talk about deep brain stimulation, which I personally think is like the coolest thing ever, and hopefully can convince you of that too. So kind of just starting generally, one of the things that is important to understand when we're talking about Parkinson's disease is what do the cells in our brain look like? Because we have a very unique type of cell in our brain that we don't have anywhere else outside of our nervous system. So the cells in our brain are called neurons. So here's a nice little picture of a neuron. One of the important things to note in this slide is just that we see that our brain